and go over this. For problem number 1, we have 20 over 2/3. 20 over 2/3. Who can tell me what they got? Allison? 30. Very good. All you're doing is taking essentially 20 and dividing it by 2/3. You're taking the 20 and dividing it by 2/3, and that's just going to give you 30. Okay, and then for problem number 2, 1/4 over 3. 1/4 over 3. Caden? Huh? It's not 3/4. Angel? 1/12. You're taking 1/4 and you're dividing it by the 3. You're taking 1/4 and dividing it by the 3. So that's going to equal 1/12. Okay, you got to be careful, guys. If you're going to type it in all the fraction form, so 1/4, you would have to type it as 1/4. Then you'd have to get out of that fraction before you hit the fraction button again. See, notice the difference. So this is what you should have done. You should have typed 1/4, gotten out of the fraction, and then hit the fraction button again over 3. That would give you the 1/12. If you don't do that, if you just hit 1 fraction 4 and then fraction again in 3, then that's really saying it's 1 over 4/3, which is going to be different. That's going to come out to 3/4. Okay, so you got to be very careful how you type it in. Okay, the best thing you can do is just notice that that larger fraction bar means that this is the top, this is the bottom. You're just taking top divided by bottom. So the easiest thing to do is just to type 1/4, get out of the fraction, divided by 3. Okay, always get out of the fraction. Once you've typed your fraction in, get out of the fraction before you do anything else. All right, for problem number 3, given these 3 ratios, which of those ratios is considered to be in unit rate form? Which one of these is already in unit rate form? Lexus? 60 miles over 1 hour. So 60 miles over 1 hour, that is already in the unit rate form. Remember, unit rate means that the denominator is a value of 1. When we're talking about unit rates, that means that the denominator is going to be a value of 1. Okay, so 60 over 1 is going to be your unit rate. Now, if a driver is traveling 120 miles in 2 hours, is their average speed 60 miles per 1 hour? Is it the same? Leslie is going, yes, it is, it is. So all you had to do is take that 120 and divide it by 2, and that comes out to 60. So yes, it is the same. What about for problem 5? Is 190 in 3 hours the same as 60 miles? Is that the same? No. See, if I take 190 and divide it by 3, what does that come out to? 63.3 repeated. Good. So that 3 is going to keep going and going and going. So no, it's not going to be the same as 60 miles, right? It's a little bit faster, just a little bit faster. Okay, so that's just reviewing what we covered yesterday with rates and unit rates. Okay, let's go to the next page. We're going to start talking about proportional versus non-proportional relationships. Proportionality versus non-proportional relationships. Okay, so we've got a few things that we're going to write into here. That's very important. So in order to be proportional, so I'm going to even highlight proportional in pink. If I say that a relationship is proportional, then that means when you're looking at your two quantities and you're comparing them to another set of the similar two quantities, they have an identical unit rate, okay? So two quantities are proportional. Okay, real big letters. They are proportional if they have an identical unit rate throughout. Okay, so you might be given, okay, I'm gonna compare, you know, hours of studying to amount of problems I complete. So if the amount of hours I study is proportional to the amount of problems that I'm completing, then that means that no matter what amount of problems I complete in a certain amount of hours, it's going to have an identical unit rate consistently throughout that kind of example. Now, on the contrary, if the quantities are not proportional, then they won't have a consistent unit rate. If the quantities are non-proportional, then they will not have a consistent unit rate. So maybe somewhere in the problem things deviate a little. Maybe the first two examples of it in the problem have an identical unit rate, but then it deviates when it gets to the third example. So you have to make sure it's consistent. Consistent means it is the same throughout the entire problem, that it never deviates. So that means in problems like these, you have to check every single example or every single piece of data to make sure it is consistent. Okay? So for here, for problem number 1, Andrew earns $18 per hour for mowing lawns. We want to know, is the amount of money he earns proportional to the number of hours he spends mowing? We want to know if it's going to be proportional. So the best thing that you guys can do is first create a table. So what are we comparing? We are comparing how much money he makes and how many hours he works. So if he starts at 0 hours, he doesn't work anything, is he going to make any money? No. If he doesn't work, he does not get paid. Right? That's the logic. That's how it works. If you don't work, you do not get paid. So at 0 hours, he's going to make $0. Now, at 1 hour of work, how much is he going to make? $18. At 2 hours, how much should he have now earned? Huh? 36. At 3 hours, how much should he have earned? Check in your calculator. 54. Let's do one more. At 4 hours, 72. Okay? So we're monitoring the amount of time he's working and the amount of money he's making. And now I need to know, is this going to be a proportional relationship? Meaning, am I going to see a unit rate that is consistent? Now, with unit rates in a table, remember, money always goes on top. right? Money always goes on top over quantity. Money's always going to go on top over quantity. You might have a quantity over time. Time always goes on the bottom. And when in doubt, if they don't have money and they don't have time and it's relating to other types of things, then it's going to be a Y value over an X value. You're always going to be checking a Y value over an X value. Keep everything on your lap. On your table. Okay? Y value over your X value. Okay? Now, here we do have both money and we have time. We have both money and time. So we can go ahead and make those comparisons individually. So let's start. First of all, we're not going to be able to do an accurate example with 0 over 0 because 0 over 0 is just going to be 0. So we're going to go to our next actual piece of data. Our next actual piece of data is going to be 18 over 1. What does 18 over 1 equal? 18. Okay, now we're going to go to the next one. We're going to do 36 over 2. What does 36 over 2 equal? 18. Okay, then we're going to go to the next one. We've got $54 in 3 hours. What's 54 over 3? 18. Then we check the next one. We've got 72 over 4. What does that equal? 18. So we've constantly got a unit rate of 18. It is a consistent unit rate. And since the unit rate is consistent, is this a proportional relationship? Yes. This is a proportional relationship because we have a consistent unit rate of 18. So let's put that down. This is proportional because we have a consistent unit rate of $18 per hour. We have a consistent unit rate of $18 per hour. That makes it a proportional relationship. Okay, let's take a look at problem number 2. Uptown Tickets charges $7 per basketball game, per basketball game ticket, plus a $3 one-time processing fee for your ticket order. We want to know, is the cost of an order proportional to the number of tickets ordered? Okay, so let's go ahead and again, we're going to make a table. Okay, so we've got the number of tickets compared to the cost. So now, if I'm ordering, before I can even start purchasing tickets, what do I have to pay? Read through the problem. $7 per basketball game ticket plus a $3 one-time processing fee for your ticket order. So if I want to order tickets, I have to pay my $3 one-time processing fee for that ticket order. So that means before I start even ordering tickets, I'm starting at a cost of $3, aren't I? Yeah. Now, once I pay that, the charge of one ticket is just an increase of $7. So, am I paying this $3 over and over and over again? No, I paid it one time. So now my price is just going to increase by $7. So, what's $3 plus $7? $10. So to buy one ticket, to buy just one ticket, I have to pay $7 for the ticket, $3 for the one-time processing fee. What about 2 tickets? How much is it going to cost me to order 2 tickets? $17, right? $7 for one of them, $7 for the second one, and $3 for the one-time fee. So 7 plus 7 plus 3, that is 17. What about for 3 tickets? 24, good. So we're just increasing by $7 every single time. So 4 tickets is 31. What's important though is that at 0 tickets, we had a starting value that was other than 0, didn't we? At 0 tickets, we started at $3 as our cost because there's a processing fee to start with. That's very important. So now if I were to go ahead and work this out, again, we're not going to focus on this one because anything divided by 0 is just going to come out to 0. Let's start here. What is 10 over 1 going to equal? 10. What is 17 over 2 going to equal? 17 over 2, guys. Come on. Here, I'll zoom in so you guys can see it a little easier. 17 over 2 equals what? 17 divided by 2? 8.5. What is 24 over 3 equal? 8. What does 31 over 4 equal? 7.75. So here's the problem. Are these consistent? No. These are not consistent. Okay, this is not consistent. So is it proportional? No. This is a non-proportional relationship. So let's write that down. This is non-proportional. Non-proportional. Because there was not a consistent unit rate. So it was non-proportional. We did not have a consistent unit rate. Okay, when we come back from lunch, we'll finish up the rest of these. All right, let's go ahead and continue to the next page. So as we stated previously, that if it is proportional, it needs to have a consistent unit rate when you make a chart. If it's not proportional, it will not have a consistent unit rate. Okay, so what I want you guys to do is number 3, 4, and 5 on your own. Do problem 3, 4, and 5. Set it up as a table, so I'll even start your table for you. So for here, Anna walks 6 miles per day. So we're going to have the number of miles, the number of days versus the number of miles. The number of days versus the number of miles. For problem number 4, recipe for fruit punch calls for half a cup of sugar to be combined with 2 quarts of juice mix. Is the amount of sugar used proportional to the amount of juice mix? So at the top, the first part will have juice mix versus sugar. And then with the bottom one, Josh has $120 in the bank. Each week he deposits $20. So we're going to have weeks compared to money. So go ahead, fill out the tables, identify whether it has a consistent unit rate, and if it is consistent, then it is proportional. If it's not consistent, it is not proportional. Okay, let's go ahead and go over this. If you didn't finish it, that's okay. Let's just go over it so we can move on to the next one. So it says Anna walks 6 miles per day. We want to know if the miles that she's walking is proportional to the number of days that she's going to walk. So at 0 days, how many miles does she travel? 0, right? Okay, at 1 day, it's how much? 6 miles. 2 days, 12, good. 3 days, it's going to be 18, good. And 4 days, I have 24. Okay, so does it have a consistent unit rate? Yeah, what is the unit rate? 6, right? If we take 6 over 1, right, miles over the days, that's going to be equal to 6. 12 over 2 is going to be equal to 6. 18 over 3 is going to be equal to 6. 24 over 4 is going to be equal to 6. So this does have a proportional relationship. It is proportional because it has a consistent unit rate. Okay, and that unit rate is 6. 6 miles per day. Okay, problem number 4, recipe for fruit punch calls for half of a cup of sugar to be combined with 2 quarts of juice. Okay, so if we have 0 juice, do we have any sugar? No. Okay, now the quarts, the juice mix increases by 2, right? So at 2 juice mixes, 2 quarts of juice mix, how much sugar is that? How much sugar? 1/2. Okay, so since this is having me go from 0 to 2, what do you think my next amount of juice mix should be? 4, right? It's having me count by 2, so why don't we just go ahead and continue to count by 2s? It makes it easier. So that's going to be 4. Okay, so for 4 quarts of juice mix, how much sugar would that be? Huh? Not 2, it would be just 1. Just 1. Okay? At 6 quarts, it would be 1.5. At 8 quarts, it would be 2. Okay, so now let's check to see if it's got a proportional relationship. So we're going to take a half and divide it by 2. We're going to take 1/2 and divide it by 2, and that's going to equal 1/4. We're going to take 1 and divide it by 4, and that's going to equal 1/4. So I'm going to zoom into the chart so you can see it easier. Okay, so think of it. This is my y value. This is my x value. And I said on the previous slide, when you're setting up a unit rate, it's y over x. Y over x. So I'm taking my y, which is 1/2, over x, which is 2, and it gives me 1/4. I'm taking the y, 1, over the x, 4, and that gives me 1/4. I'm going to take the y value of 1 and 1/2, and I'm going to put it over the x value of 6. That's going to come out to 1/4. I'm going to take the y value of 2 and put it over the x value of 8, and that's going to come out to 1/4. So do I have a consistent unit rate? Yes, there is a consistent unit rate there. So that means that this is a proportional relationship. Okay, because again, proportional relationships have consistency. It has a consistent unit rate throughout. And consistent unit rate, so the unit rate has to be found by taking the y value over the x value. Okay, let's take a look at the last problem. Josh has $120 in the bank. $120 in the bank. Each week, he deposits another $20. So is his account balance proportional to the number of weeks that he's depositing? So at 0 weeks, how much money does he have in the bank? 120, right? He has $120 in the bank. So before he even starts depositing his $20 every week, he's starting at 120. Now, each week, he's going to deposit $20. So what is that going to happen? What's going to happen to the bank account? It's going to keep going up by how much? $20. So at 1 week, it's at 140, right? It's not at 20. At 1 week, it's not at 20. At 1 week, it's now at 140. Because at 0 weeks, we were at 120. Each week, we're going to increase by 20. So we're now at 140. By week 2, what are we at? 160. By week 3, what are we at? 180. By week 4, we are at 200. Okay, so is this going to create a consistent unit rate? No, right? If I take my Y value, my money, Y, over my X value, my weeks, right? Money always goes on top, so that's always the Y. Weeks always goes on the bottom, because that's the X. So 140 over 1 gives me a unit rate of 140. But then 160 over 2 gives me a unit rate of 80. 180 over 3 gives me a unit rate of 60. 200 over 4 is going to give me a unit rate of 50. Is this consistent? No. This is not a consistent unit rate. My unit rates are different. So this is a non-proportional relationship. Non-proportional because there is no consistent unit rate. Okay, it's not proportional because there is not a consistent unit rate. Now, I want you guys to take a moment and look at each of the examples that were proportional and look at the table. So we've got how many examples were proportional? We had 3 total, right? We had problem 4, problem 3, and problem 1. What did their tables have in common versus the non-proportional relationships? What do those tables have in common? So let's see if we can figure out something besides just unit rate. What else are we noticing about the table of information? Brianna? Say it louder. It's what? Yeah, so if the X is a 0 and the Y is a number, that's always creating a what? A non-proportional relationship. However, with the proportional ones, when X is 0, Y is 0, isn't it? So if you relate this back to equations, this $20, I'm constantly increasing by $20, that's a coefficient, guys. That starting at $120, that's a constant. If you see a problem that has a starting value, so when you start, you have a starting number before you are consistently increasing, it's a non-proportional relationship. If it does not have a starting value, if both will be set at 0, 0, when one is 0, the other would have to be 0, that is creating a proportional relationship. Here's why. Let's go to page 74 in our notes. Page 74. Another way to determine proportionality is through a graph. Here's what's really important. With the graphs, if in the graph, if the graph is a straight line through the origin, who knows another way of saying the origin? What point? What point is the origin? Caden? 0, 0. The origin is at 0, 0. Does that ring a bell now? Hey, we just had a bunch of tables that when they were proportional, their very first value was 0, 0. That's called an origin when you're graphing it. So if you're graphing a straight line, has to be straight, and it goes through the origin, then it is a proportional relationship. Very important. Straight line, and it goes through 0, 0. You have a proportional relationship because it means you are consistently increasing or decreasing by the same value, but your starting point is always 0, 0. Okay, so let's take a look here. Plotting. Let's just focus on plotting points. So number of tennis balls versus the cost of purchasing them. So let's go ahead and say that this side is our x and this side is our y, because when we plot it as x comma y. X comma y. So if it's a positive 3, then I'm going to go to the right 3. I'm going to go 3 to the right. And then it's a positive 6. That means I'm going to go 6 up. When I plot, I'm going to go 3 to the right and 6 up. So I'm going to start here at 0. And I'm going to go 3 to the right. 1, 2, 3. And then 6 units up. 1, 2, 3, 4, 5, 6. Right here. There's where my first point is going to be. 4, 8. 4, 8 means I'm going to go 4 to the right and 8 up. So 4 to the right and 8 up puts my next point right here. We're going to go 5. 5, 10. That's 5 to the right and 10 up. 5 to the right, 10 up. Plots that point right here. 6, 12. 6 to the right, 12 units up. 6 to the right, 12 units up. Puts that point right there. So then we have to go ahead and connect those points and see if when we connect it, does it form a straight line? That's the first question. The second question is, will it extend that straight line to the origin? If the straight line can extend to the origin, then you're good. Now, when you're connecting them, are you going to connect them freehand? No. Because you don't have a straight line hand, do you? You're going to need a ruler. So you need to make sure that when you're connecting them using your ruler. Okay, so I have a ruler. I'm connecting the points. I'm extending it. When I extend it, does it touch the 0, 0? Yes, it does touch 0, 0. Even though 0, 0 wasn't in my table, I can extend my line to see if it's going to be straight. Is it straight? Is it straight? Yes. And can I extend it to 0? Yes. So the fact that it is a straight line, I've got my checklist, straight line, that's true. Origin, that's true. So then it means that it is proportional. It is a proportional relationship. Now, unit rates. Unit rates are easy to find. A unit rate is when x equals 1. A unit rate is when x is equal to 1. So when I'm looking at my graph and I want to know where my unit rate is, I'm going to go to where x is equal to 1, and I'm going to follow it up until I can cross the line. There's my unit rate. What's my unit rate in this problem, guys? 2. My unit rate is 2. And that would represent 2 what? 2, what's this? Total cost, $2 per number of what? Tennis balls, right? So it's $2 per tennis ball. It's $2 per tennis ball. You need to make sure you know how to relate it back to the graph. Let's take a look at the next page, page 75. I want you to plot these points on the graph and then tell me, is it going to form a straight line? If you don't have a ruler, you could use the calculator as a straight edge. Just be careful. You can use your calculator as a straight edge if you don't have a ruler. All right, let's go ahead and plot it real quickly. So 1, 4. 1, 4 means we're going to go to the right 1 and up 4. 2, 8 means we're going to go to the right 2, up 8. 3, 12 means we're going to go right 3, up 12. 4, 16 goes to the right 4 and up to 16. If we connect them, will it form a straight line? Yes. Will it go through the origin? Yes, it will. Okay, if you connect them, it will form a straight line. It will go through the origin. Okay, so that's why you got to be very careful. You got to be very careful. A ruler is really the best thing that you can use, okay? So it does go through the origin. It does create a straight line. So straight, correct. Origin, correct. That makes it proportional. Let's identify the unit rate. What is the unit rate? 4. Very good. Remember, unit rate is when x is equal to 1. So we're going to follow it over to where x is equal to 1. And we're going to follow it up until we hit the line, which happens to be right here. That is our unit rate. Okay, so the unit rate is equal to 4. And let's put it in terms of what the graph is. It's 4 what? 4 quarts. Right? It's 4 quarts for 1 gallon. 4 is on the y-axis, so it's 4 quarts for 1 gallon. It's 4 quarts per gallon. 4 quarts per gallon. Okay, let's take a look at the last 2 examples for graphs. Or one of the last examples for graphs. Page 76. We'll have to finish the rest of this tomorrow, okay? Baking. Rachel baked 3 cakes in 2 hours. She baked 3 cakes in 2 hours, 4 cakes in 3 hours, 5 cakes in 4 hours. Okay, so if I were to create this as a table, if I were to create this as a piece of a table of information, we'll use orange. X is going to be my what? What's my X say? My X-axis is labeled what, guys? Hours. So we have X hours versus Y, which represents my what? Look at your axis. Your cakes. Y represents your cakes, right? This is your X-axis. This is your Y-axis. So X hours, Y cakes. So let's start here. 3 cakes in 2 hours. So we have 2 hours, 3 cakes. 4 cakes in 3 hours. So we have 3 hours, 4 cakes. 5 cakes in 4 hours, that's 4 hours, 5 cakes. Let's go ahead and plot those. So 2, 3. We're going to go right to where the 2 is. Not 2 boxes, but where the 2 is. And then up to where the 3 is. Okay, right to the 2, up to the 3. Then we're going to go right 3, up 4. Then we're going to go right 4, up 5. And then we're going to go ahead and connect them and see if it creates a straight line. Is it going to create a straight line, guys? No. It's not? Yeah. It is. It's a straight line. Is it going to go through the origin? No. No. So it's straight. The straight is fine. Origin, that's a big no-no. It didn't happen. So is this proportional? No. This is non-proportional. This is not proportional. Okay? We have time to do the last one because you don't have computers to put away. So let's go ahead and do the last one. Turn to the next page, do the last question. Or we'll do it real quickly together. Page 77. Calories. A person can burn 8 calories per minute. 8 calories per minute. We want to determine if it's proportional or not. So let's go ahead. Minutes. Shh, quiet. Quiet. Minutes is going to be our X. Minutes is going to be our X. Calories is going to be our Y. So at 1 minute, it's going to be 8 calories. At 2 minutes, it would be 16 calories. 3 minutes, it would be 24 calories. I only need a couple of points to plot. So at 1, we're going to go up to where 8 would be, which is roughly around right here. At 2, we're going to go up to where 16 is, roughly around here. At 3, we're going to go to where 24 is, which is roughly about here. And then we're going to go ahead and connect. When we connect it, it does form a straight line, and it does hit the origin. Straight line through the origin. So this is straight. This is through the origin. So it is proportional. Tomorrow, we're going to learn how to solve proportional relationships, and we'll do some practice on all of this. Go ahead and pack up.